All right. So, hello everyone, and welcome back. So, I know it's been a while since I last posted, but today let's get straight to the point. So, we'll be deriving the heat diffusion equation in terms of the spherical coordinates. So, again, regarding heat transfer. So, yeah, since uh, my primary audience, of course, is my classmates and other students as well. So, we have done the Cartesian and the uh, cylindrical coordinates. So today we'll be doing the spherical one. All right. So it's basically the same process. So before we derive anything, so let's have our steps in deriving the heat diffusion equation. So first, we must define the differential control volume. So ayun nga, it's important to know the difference between the control volume and the differential control volume. When we speak of differential control volume, it's just a segment of the control volume itself. So we'll see that later on. And for the second step, we have to utilize our energy balance equation. So it's basically our energy in minus our energy out plus our energy generated is equal to energy stored. And we have to note that whenever there is an energy in and an energy out, there's a surface, meaning that there's an area. And whenever we have uh, energy generated and energy stored, that means we have volume, since both of those are volumetric phenomena. Okay, so for the next step is just to modify our energy balance equation with our heat rate equation. So we will substitute our equations here and try to simplify it as much as possible. Okay, so let's move on to the derivation. So we'll be looking at the spherical coordinates in terms of our directions. So we have r, phi, and r theta. Okay? So looking at a sphere, ano? So kuha tayo ng segment or a differential control volume from the sphere. Okay? So huh? Let's try to have our laser. Okay, yeah. So when we take our control volume, our differential control volume, we notice that we have our coordinates. Ano? So we have our dr, our rd theta, and we have our r sine theta d phi. So the reason for sine here is because yun nga, our theta is approaching uh, here and it is inclined in the y direction. So whenever we have the y direction, so so katawa, it is just yung ating sine. No? So it's the opposite side over the hypotenuse. And, and taking into account yung mga napasok na energy and yung nalabas na energy, uh, in terms of heat, rather. So, tingnan natin, we have our QR, pasok dito. Oh, QR here, and we have our QR plus DR. So, yun yung palabas na QR. And then the same goes for Q phi and Q theta. So, they have their respective uh, energies na napasok at nalabas. Ayan. And now we have to apply our steps. So, first, we have to define yung ating volume, our differential control volume. So, that would be dV. No? dV. So that would be dV. That is equal to yung ating uh, various coordinates of yung ating spherical coordinates. So that would be dr no, times rd theta times r sine theta d phi. And further simplifying this, our dV would be r squared no, sine theta. And the way I like it, so ang gagawin na lang natin is unahin natin yung dr and then yung phi and then yung theta. So we have dr, d phi, and then d theta. Ayan. Since yun nga, yung ating coordinates is in terms of r, phi, and theta. Ayan. So now that we have our control volume, we will utilize yung ating energy balance equation. So the energy balance is just, again, nothing E in minus E out plus our energy generated. That is equal to our energy stored. Ayan. And define na tayo ng values for our each of the variables. So for E in, no, edi tingnan natin yung lahat ng uh, energy na napasok. So that would be the ones highlighted in red. So we have QR plus Q5 plus Q theta. Okay. And for our E out, no, then it would just be the ones highlighted in blue. Okay. So that would be QR plus DR plus Q5 plus D5, then plus Q theta uh, plus D theta. And then for our energy generated, no, that would just be yung ating Q dV. And our dV is ito, r squared sine theta dr d phi d theta. And then for our energy stored, no, again, the energy stored would just be cross Cp. And then yung ating dV, which is this, squared sine theta dr d phi d theta. And then yung ating partial derivative of temperature with respect to time. So, yun yung ating energy stored. Okay? Now, these values, meron din silang corresponding equations. Okay? So, simulan mo natin sa ating energy. Okay? So, sa ating QR, again, we apply Fourier's law. So, that would just be KA, since that's the area. But yung ating area is kukuhanin natin dito. Okay? So, let's just do that. So, sa ating K, sa ating QR, we have yung ating, unahin natin yung in terms of phi. So, that would be r sine theta, right? D phi, right? D phi times r d theta. Okay? And that is the partial derivative of the temperature with respect to r. Okay? And now we can simplify this. No. So, since we're taking the partial derivative, all other variables that are not in terms of r will be held constant. So, pwede nating ilabas yung ibang variables here. Okay? And ipapasok natin sa partial derivative yung ibang signs na nandito. So, we will have negative sign, theta, d phi, d theta, and then the rest, ipapasok na natin sa loob ng ating partial derivative. So, we have k. Since k is basically yung ating thermal conductivity. So, it's a constant, but we can define it as a part of the partial derivative. We have r squared and then dt over, the partial derivative of t over r. So, ayan. This is our QR. Okay? For our Q phi, okay? For our Q phi, no. So, again, negative k and yung ibang coordinates dito na not in terms of phi. So, that would be times dr times rd theta. Okay? And that would be the partial derivative of the temperature with respect to r sine theta p5. Okay? Now, we can treat yung ating r sine theta as a constant, so we can cancel some values here. So, cancel natin tong r, like so. No. And then we can simplify this. So, ilalabas na natin yung sine theta dito. And then we can let yung ating k sa loob ulit ng ating partial derivative. So, that would be equal to negative dr d theta over No? So, ilabas na natin yung 1 over sine theta dito. So, i-multiply na natin dito. Sine theta, and then yung ating partial derivative, what would be k dt uh, over d phi. Ayan. So, this is our q phi equation. And then, yung ating q theta. Our q theta is, that would be negative k. And then again, yung mga not in terms of theta is ilalagay natin, will be dr times r sine theta d phi. Okay? And then the partial derivative of temperature with respect to r, then gawin natin yung partial derivative yung ating r d theta. Okay? And again, yung r, we can treat it as a constant, so we'll use it to cancel this. Ayan. And then, ilalagay natin yung k sa loob. And then, since we notice that it is in terms of theta, and sine is a function of theta, no? So, ilagay din natin siya sa loob ng ating partial derivative. So, we have negative dr, right? And then we have d phi, right? And then yung ating k sine theta, partial derivative of temperature with respect to theta. Ayan. So, this is our equations for En. So, i-substitute natin to lahat sa energy balance later on. But now, let's look at our E out. Okay? So, for E out, ayan. So, for E out, we have QR plus DR. Again, when we're deriving yung ating heat diffusion equation in terms of the Cartesian coordinates, since that's it, that is the first thing na dinerive natin, we apply yung ating Taylor series expansion that we learned in advanced mathematics. So, marami yun, but we will just look on the first iteration. So, that would be ating QR, no, plus the partial derivative of QR with respect to R. No. So, yeah, ayan yan. Okay? And then, ang ating Q phi plus D phi, same concept. So, that would be Q phi plus the partial derivative of Q phi over D phi. Okay? And then, yung ating theta, so Q theta plus D theta is equal to Q theta plus the partial derivative of Q theta over theta. Okay? With respect to theta. Ayan. Okay? Okay. And then, yung ating partial derivative of the respective heat equations is meron pa din silang sariling equation. So, if you observe it, no. So, basically, yung ating partial derivative of QR with respect to R, that is just itong equation natin, but we put yung ating partial derivative sa labas, okay? So, that is that. And, ayan, let's just do that real quick. So, our partial derivative of QR with respect to R is negative sine theta d phi d theta. And then what we can actually do here, no. So, before the partial derivative here, ilagay na natin yung partial derivative dito. Okay? So, ayan. KR squared. Ayan. Okay? And the same goes for the other two. So, the partial derivative of Q phi with respect to phi, that would be equal to negative dr d theta over sine theta, and then yung partial derivative, ayan, and then yung nasa loob. What you can actually do is, pwede rin siyang gawing second partial derivative na. But just in terms of the formality na ilalabas natin yung lahat ng partial derivatives, we can simplify that later. But for now, uh, let's do it the way that it is intended. Ano? So there are multiple ways you can go about this. So this is just one way of it. And for the partial derivative of q theta, with respect to theta, right, to be equal to ito plus yung ating partial derivative. So we have negative dr d phi, okay? And then yung ating uh, partial derivative with respect to theta. And then itong nasa loob. K sine theta, partial derivative of temperature with respect to theta. So, and now that we have our equations, okay, we can substitute them to our energy balance equation. So, gawin na natin. So, again, let's rewrite yung ating energy balance equation. Ayan. Okay. So for our En, so we have Qr plus Q phi plus Q theta. And then that is minus the, we have Qr plus the partial derivative Qr over R plus yung ating Q phi plus the partial derivative of Q phi with respect to phi. Again, just trivial process, okay? Q theta and then yung ating energy generated, that would be Q, and then lagay na natin yung ating volume. So that is r squared sine theta dr d phi d theta, and then sa baba. So I guess we can just extend this, ano? Hold on. Extend natin siya ng konti. Ayan. That is equal to our energy stored, which is rho Cp, and then again yung ating volume, our differential control volume. D theta, partial derivative of temperature with respect to time. And ayun nga, as we can see, there are units that we can already cancel since we have a negative here. We can cancel all yung mga independent na heat. Okay? So, ayan. Alright. Then, after canceling, ano, pwede natin gawin is we can substitute our values for the partial derivatives and further simplify. So, para mas mapadali na natin yung process, so, ang gawin na lang natin is we can factor out yung ating dr, no, yung ating dr, yung ating d phi, and then yung ating d theta. So, we will factor this out dito sa ating tatlong partial derivatives, right? And then we can cancel it later on. Okay. So, first, gawin muna natin ay, gawin natin is we will put the partial derivative at front. So, we have the partial derivative ng r, right? And then, yung nasa loob nito, we have kr squared sine theta, and then the partial derivative with respect to. So, pinasok muna natin yung sine theta sa loob ng partial derivative since ilalabas natin yung dalawang units for the volume. Okay, and then plus, no, so for phi, okay, for phi, ang gagawin natin is, again, yung ating partial derivative of phi. Then, itong sine, pasok muna ulit natin sa partial derivative. So we have k over sine theta, right? Sine theta, partial derivative of temperature with respect to phi. Ayan. And then, plus yung ating partial derivative with respect to theta. And then, we just copy this since nasa loob na yung set. Okay. K sine theta, partial derivative of temperature with respect to theta. Ayan. And then, nasa labas yung ating dr, d phi, and then ating d theta. Since they all have these multiples. No? And then, medyo zoom out natin a bit so we can fit in the rest of the solution. So, yung ating Q. So, you have yung ating energy generated, that is Q, R squared sine theta, dr, d phi, d theta is equal to sa ating energy stored, which is rho Cp, and then yung ating volume. Let's zoom it out a bit more. And rho Cp r squared sine theta dr, d phi, and then d theta, partial derivative of temperature with respect to time. So this is our whole equation. And now what we're gonna do is we're gonna divide the whole equation by, so I'll guess a different color for this one. We will divide our whole equation by r squared sine theta dr d phi and then d theta. Ayan. So for starters, we're gonna distribute first yung ating r squared sine theta dito sa values na to, but we're gonna cancel out yung ating other values, such as this. This will get cancelled as well, and then this will be cancelled as well. Okay. All right. And then moving on. Okay, moving on. So distribute natin yung r squared sine theta as a fraction dito. And then we can further simplify kung ano makakancel natin. Okay. So let's zoom it again. And so I have 1 over r squared sine theta. So, ayan, ito yan. And then, copy lang natin to. So, I have partial derivative of r, right? And then, yung nasa loob, a r squared sine theta dr. And then, plus, again, we're just distributing 1 over r squared sine theta. And then, now we have partial derivative of phi, then over k over sine theta, right? And then partial derivative with respect to phi, right? Yeah, plus 1 over, zoom up natin, 1 over r squared sine theta, and then yung ating partial derivative in terms of theta, and then kung ano nga sa loob, a sine theta, partial derivative in terms of theta. This is plus q, and this is going to be equal to rho Cp. Yeah, that's it. Rho Cp, yeah, partial derivative of temperature with respect to time. So, isa lang natin. Yeah. Okay. And now, you may notice that we have some units to cancel. So, makikita natin dito, sine theta is considered as a constant here. So, we're just gonna cancel yung ating sine theta. You may be wondering, r squared, and then we also have a r squared here. So, can we cancel that? Technically not, since it's not a constant here. No. Yung ating r squared is kinukuha natin yung kanyang partial derivative in terms of r. So, we cannot cancel that. Okay? So, ito na yan. Ito na yung final simplification na gagawin natin dito for this part. And then, moving on to the phi. Sa ating phi is, I don't think there's anything to cancel here, no? So, wala tayong kakancel dito. But we're just gonna simply transfer yung ating sine theta dito. So, it will be sine squared theta. So, let's do it later on. And for this one, no, for this next part, I don't think there's anything to cancel as well, since we cannot cancel sine theta because we're taking the partial derivative of sine theta in terms of theta as a partial derivative. Okay. So, yun. So, ito lang yung na-cancel natin. Okay. And now we just have to simplify. Okay. Yeah. So, we have 1 over r squared. No, so we have the partial derivative in terms of r. And now we have kr squared partial derivative with respect to r of temperature plus, no, now we have 1 over r squared sine squared theta. No, so this is partial derivative, partial derivative in terms of phi sa loob yung ating k. Yan. And then we have here, dito na wala tayong babaguhin, right? Yeah. So we'll just copy this one. So we have 1 over r squared sine of theta, the partial derivative with respect to theta, and then k sine theta, partial derivative with respect to theta, plus q equals rho Cp, partial derivative in terms of temperature. Ayan. So, in general, this is our equation. So, let's just plot it. Natin siyang plots. Like so. And so, this is our heat diffusion equation. In terms of sa ating spherical coordinates. So this is our general equation. No, but now that we have our general equation, no, we now have to consider yung ating assumptions. All right. So we have pertinent assumptions that we will use to simplify the heat diffusion equation. So on the heat transfer that we are discussing, we have four pertinent assumptions. So lagyan lang natin dito. So we are generally applying yung ating general assumptions. Okay? So first, no. So first assumption natin is that we have constant properties. Meaning that your K is constant all throughout the process. Okay? So what this basically means is you have to divide all sides by k. No. So we will just rewrite the equation here. So that is basically 1 over r squared, partial derivative of r. Now, alisin lang natin yung k. You have r squared, partial derivative of temperature with respect to r, plus 1 over r squared sine theta, right? Partial derivative of phi. And now, alisin na natin yung k dyan. So, this is what we're left with. If you want, you can make this into the second partial derivative of phi, of the temperature with respect to phi. So, it's up to you. But ilagay ko na siyang ganito para uniform yung solution natin. And then plus 1 over r squared sine theta. No? And then we have the partial derivative in terms of theta. And now we have sine theta. Yeah. Okay? And now, gagawin natin is, again, like I said, we're dividing both sides by k. So, we have q over k. And that is equal to rho Cp over k. Ano? So, our formula for thermal diffusivity, alpha, is, that would be yung ating k over rho Cp. If we have rho Cp over k, then it would just be technically yung ating reciprocal ng thermal diffusivity. So that is 1 over alpha, which is what we'll use. So 1 over alpha, no, 1 over alpha, and then yung ating partial derivative of temperature with respect to time. So this is the equation for constant properties. No. So for the second equation, or for the second assumption rather, we have no internal heat generation. So basically, Q is equal to 0. So ang gagawin mo lang is you use this whole equation again, but you remove your Q. So that's it. Yun lang gagawin mo. And for the third assumption, we have steady state conditions. And which basically means that yung ating partial derivative of temperature with respect to time is equal to 0. So what that means is, itong side naman na to, ang magiging 0 na. So again, you just repeat the whole equation, and then this side is 0. No, since it's steady state. Okay. And for the fourth assumption is that in terms of direction, so let's say it is one-dimensional. For, let's say, in our direction. So ang gagawin mo lang dito is that you will neglect all the other variables na nagpe-pertain sa ibang direction. So ang consider lang natin is this. So ito lang. If we're talking about sa ating R. No. So let's just write that down. So we have 1 over R squared, and then yung ating partial derivative with respect to R. And then we have KR squared dt over dr. And now we directly go to Q equals rho Cp dt over dt. So ayan. So you could also assume that it would be one-dimensional in the phi direction, the theta direction, or it could be two-dimensional. So if it's in a surface, it could be two-dimensional in r, in phi, in theta, or in phi. So ayun, it's up to you to modify this equation on how you will base your assumptions. But technically we still have a fifth one. No, and that is in the case if all pertinent assumptions are applied. No. So again, we just look at this equation again since ito na yung one-dimensional in our direction, and we will apply yung ating three other equations. Okay? So, ang gagawin lang natin is we have 1 over r squared, right? And then yung ating partial derivative with respect to r. And again, constant properties, remove the k. So we have r squared, uh, partial derivative of temperature with respect to r. No. And then we don't have yung internal heat generation. So Q is 0. So we omit that. And then we also assume that it is in steady state condition. So our partial derivative of temperature with respect to time is 0 then. So this whole equation here is equal to 0 na. No. And then again, you can solve for the general solution of this since it is a second order differential equation. So, but I'll leave that up to you guys on how you will try to solve it. Okay. So, ayan, this is the final, so this is the final derivation, no, or the final process on deriving the diffusion equation in terms of the spherical coordinates. So, ayan, I hope you guys have learned something. So, I hope you can use this in the upcoming quiz in case that we are asked to derive this. So, ayan. And ayun lang naman. I I'll see you guys whenever I guess whenever I want to make another video. So, ayan. Again, thank you guys and goodbye.